Hey y'all, just wanted to make a quick video to help you with some additional topics in ALEKS that we didn't get to in class today. The first one is going to be this top problem type where we are given a function each and we are asked to find two functions f and g. And the functions so we are going to identify f and g, and we want f and g to be functions such that the function that we're given, h of x, is going to be a composition of two functions, f of g of x. Okay, so notice here, g of x is my inside function, and f of x is the outside function. I don't recall if ALEKS switches the location of f and g here in its problem types for this specific topic, or if it's always going to be f of g of x. So as you're doing it, just make sure you pay attention to this notation and which function is your inside function and which function is your outside function, because the way that they're labeled will affect how you input your answer. But basically, we're trying to figure out what the inside function is and what the outside function is so that when we compose them, we end up with the function that we're given. So number one here, let's just start with this one. What you want to do is identify an inside function and an outside function. That's really how I want you to look at this. The inside function here, hopefully, if there's an expression that you can describe as being inside something else, most of you will see that the expression 2x squared minus 5 is inside something else. The outside function that it is inside of is the absolute values, right? And so if it's inside something like this, just go ahead and put an x in there so that when we take the inside function and plug it in for x, we get what we have to begin with. So here our inside function is 2x minus 5, and our outside function is going to be the absolute value of x. And we are told here how to label them as f and g. Our inside function here, that's going to be g of x. Our outside function is going to be f of x. And notice if we compose these and we do f of g of x, I'm going to start by plugging x into g, and when I do that, 2x squared minus 5 will come out. And then I'm going to take 2x squared minus 5 and plug it in for f, and I will get the absolute value of 2x squared minus 5, which is what we started with. So I know that my functions are correct. So g of x is 2x squared minus 5. F of x is the absolute value of x. Figuring out what these two functions should be is the whole goal of these problems. Now, something interesting about these is that, sorry about that. Something interesting about this is that there's not a single unique answer to this. There are alternative options here. For example, what if I had said, well, I think I see my inside function as being 2x squared. Well, if my inside function was 2x squared, then the outside function that is plugged into is going to be the absolute value of x minus 5. So my g of x could have been 2x squared. And in that case, the f of x that went with it would have been the absolute value of x minus 5. Or I could have said, no, my inside function is actually x squared. In that case, my outside function that would correspond to that is the absolute value of 2x minus 5. If I take this g of x and plug it into this f of x, I also get the original function. So there's not a unique answer to these. ALEKS will take any of these different alternatives. It will accept any of them. So your goal is just to find n inside function and n outside function that work together to create your h of x. So let's try number 2 here. What expression would you consider as being inside another function? Most of your brains will see 5x to the fourth plus 1 as being the expression that's inside something else. Again, this is not the only answer, but this is the one that most people's brains see first. And in that case, if that's our inside function, our outside function here is going to be the cube root function. And so I'm going to say the cube root of x. So then when I take my inside function and plug it into the cube root of x, I get what I started with. Again, Alex will tell you how it wants these labeled. Here, g of x is my inside function, f of x is my outside. And this is not the only solution. There are many different options that would work. Last one is number 3. Again, most of your brains are going to see the function or the expression 8x minus 3 as being the thing that's inside something else. Most of your brains are going to pick out that one as being your inside function. And then the outside function, the thing that that's inside of, is a squared function. So that's going to look like x squared. You're essentially just replacing your inside function with x to get your outside function. And so again, this tells us to label the inside function as g and the outside function as f, so these two would work. Again, that's not the only solution. You could have said 8x was your inside function, in which case x minus 3, that quantity squared, could be your outside function that corresponded with it. As long as your f and your g work together to create h, Alex will accept it. All right, so hopefully that example makes a little more sense. Let's do the last one, which is a word problem here. Okay, so the surface area, S of r, in square meters of a spherical balloon with radius r is given by S of r equals 4 pi r squared. The radius, p of t, in meters after t seconds is given by p of t equals 8/3 t. Write a formula for the surface area, n of t, in square meters of the balloon after t seconds. Okay, so there's a lot going on here. So let's start to unpack all of the stuff that's given to you in this problem. So we're given a couple of functions here. So we have there we go. We have s of r equals 4 pi r squared. Okay, so this function, what's going into this? What's coming out of this? What does this function mean? Okay, so r is your input variable. Let's start with what goes into this thing. My input is r, and that r represents the radius of a balloon in meters. So this is going to be a radius in meters. So a radius goes into this function, and what comes out of this function? Let's see, S of r, that's surface area in square meters. So you put a radius in, and you get surface area out. Okay, so that's S of r. You put a radius in, you get a surface area out. All right. We've got another function. Let's figure out what this one's all about. P of t equals 8/3 t. So what goes in and out of this function? So P of t, t is my input variable here, and t is, here it is, t is seconds. So t is time. So we're going to put a time in seconds into this function. And what is coming out of this function P? Let's see, right here, the radius, P of t in meters. So this actually represents the radius in meters. Okay, so in P, we put time in seconds in, and we get a radius in meters out. Okay, and what are we asking for? The goal of this problem. We're asked to write a formula for the surface area n of t of the balloon after t seconds. So we want to write a function where t, the time in seconds, goes in and surface area comes out. And it says it wants us to call that function n of t. We don't know what that's going to look like right now, but I know that I want surface area to come out. And I know that I want time to go in. Okay, so I want time to go in, I want surface area to come out. And I'm not given a function where time goes in and surface area comes out. I have a function where time goes in and a radius in meters comes out. And I have a function where a radius in meters goes in and surface area comes out. Hopefully, do you notice that in what I'm given, this is a radius is coming out of P and a radius is going in to the function S. My output here matches my input here. These represent the same things. So I can actually take the output here and plug it into that function. That would make sense because they represent the same thing. So really what that would be is I'm taking the output of P of t, I'm taking the y value, and I'm plugging it into the function s. So I'm taking P of t and I'm plugging it into s. Now let's think about what this would do. Oops, sorry. Um, if I do this, overall time in seconds goes in, and then a radius comes out here, and then I'm going to take that radius and I'm going to plug it into S. And overall, I'm going to have a surface area out of here. This will give me a function where time goes in and surface area comes out. That's what I'm looking for. So this function, S of P of t, this is what we're looking for. Okay, so let's actually figure out how to go through and find that function. So S of P of t, here we go. What does this look like? This notation says take t and plug it into p. When I take t and plug it into p, I get 8/3 times t out. Now my notation is saying, hey, take that and plug it into s. I'm going to come up here to s, and I'm going to plug in 8/3 t for r. And I'm going to get 4 pi r, which is 8/3 t squared. All right. So now we just have to fight through the arithmetic here. I'm going to have 4 times pi, this thing squared. Everything here is connected by multiplication and division, which means I can apply this exponent to everything in here. I'm going to square 8/3, and I'm going to get 64/9. I'm going to square t, and I'm going to get t squared. So I'm going to multiply this all out. This is 4/1 when I multiply my functions across, or my fractions across. 4 times 64 is 256. And 1 times 9 is 9. And then I'm going to have a pi and a t squared here. I don't have any other simplification I can do. This is what we've got. And this is my function. Time in seconds goes in, surface area comes out, and the problem said to name that function n of t. That is my function n of t. So the hard part about this is that you need to figure out what's going into and out of all of the functions that you're given. you're going to be able to plug one of your functions into the other to achieve your goal. You just have to figure out which one can go into the other function based on the units. The units are going to tell you that, the units and what they represent. All right, so hopefully that is helpful. I hope you have a lovely weekend, and I will see you on Monday.